Hello students, welcome back. And now we are going to talk about capacitors and inductors. So capacitor is basically going to store your charge, and the capacitance of a capacitor is given by epsilon A by D. So here we can see that capacitance is given by epsilon A by D. Now, the current in the capacitor and voltage across the capacitor, they are related with I is equal to C dV by dt. That means if I take the inverse of this equation, I can say V is equal to 1 by C integration of I dt. But there is one very important point here, that we should include the initial voltage also. Now, capacitor, when they are subjected to DC voltage or current, then they will show infinite resistance or impedance, what we name. And if they are showing infinite impedance, then they will work as an open circuit. For DC, it is open circuit, and for AC, it will be opposite. That means they will show some impedance. And if the frequency of AC signal is very high, then capacitor will become short circuit. So for DC, the capacitor is open circuit. And one quantity which cannot change abruptly for the capacitor, that is the voltage across capacitor. So please remember, whenever you are dealing with capacitors, the voltage of the capacitor cannot change immediately. The current can change. So this is a very brief example, that if I have current equal to this and this is the value of capacitance, then initial voltage is also given to be 0. Then find that what is the voltage. So the formula of voltage was 1 by C integration I dt plus V0, where V0 is already 0. We just integrate this I dt, which is this equation, from 0 to t, and we got this as our voltage equation. Now this is another example which is graphical in a way, where voltage across capacitor is given and we are asked to find current across the same capacitor. You can see the calculations, they are fine, but one thing let us observe, that from 0 to 1, the voltage across capacitor is linear. So there is a slope, and the slope value is 50 by 1. Y-axis value is 50, x is 1. So the current will be dependent on this slope value. Thus current will be I is equal to C dV by dt. So when we do it, then we find that current is plus 10 milliampere. So it will be a constant value. And for t equal to 1 to 3, we are going down with the same slope with a minus sign. So the current value will be minus 10. And from 3 to 4, it is plus. So again, we got a constant current. Now when you are putting capacitors in series or parallel, so when n number of capacitors, they are in parallel, then equivalent capacitance is the summation of all of them. And when you have n number of capacitors in series, then 1 by C equivalent is 1 by C1 plus 1 by C2 and so on. This is very basic thing we already know. Now let us talk about inductor. Inductor is basically a coil which will conduct the current. Now inductors, the voltage and current relation is V is equal to L di by dt. In the inductors, the current is the quantity which will not change abruptly or immediately. The voltage can change. So for a DC signal, the inductor will behave like a short circuit, and when you have AC signal, the inductor will show some impedance, and for a very high frequency AC signal, the impedance will be very high and it can become like open circuit. So current is the quantity which will not change instantaneously. Now this is another example. For inductor, the inductor value is given, voltage is given, and we are asked that how much energy is stored. So energy storage formula is half Li square. So we just apply it. So basically first I need to find I, and I is 1 by L integration V dt plus I0. Here it is given the value of VDT is given, that means VT is given, this is the value. For t less than 0 it was 0, so initial it will be 0. We take it, we integrate it, and we find the expression. When you are putting inductors in series, then the total inductance is summation of all of them, L1 plus L2 till Ln. And when you are putting them in parallel, then 1 by L equivalent is 1 by L1 plus 1 by L2 plus so on, just like resistors. So friends, this is the introduction to capacitors and inductors. Now in the next video, we will see the first order circuit analysis.